Megan's going to yell at me on Monday. You said you would. So Megan, I'm just getting to so you missed the beginning. Sorry. So navigation, you get the quick version of this. Navigation planes north going counterclockwise, or going clockwise, this direction here. So 110 degrees starts at north, 110 degrees clockwise. Bearings, 3 digits, 0, 6, 0 degrees. So when you're going from point A to point B, your bearing starts at north, 60 degrees here, and this is your path. But if you're going from B to A, we're going this direction, 240 degree bearing. It's just a matter of where you're going, from where to where. Surveying is always off the north-south line. So this is this path right here. This is 20 degree angle. You're going north and then 20 degrees east. In the next example, we're going south, 30 degrees west. This angle here is 30 degrees. And then the last example, north, 50 degrees west. So this is your path. Everybody good on those two, bearing versus surveying so far? You don't need to use a protractor. You don't need to use a compass. But you do want to draw a somewhat accurate picture. When you don't do a somewhat accurate picture, you may think, because you're looking at it, you're expecting one thing, your answer gives you another, it's not going to make sense to you. Okay, so course and bearing surveying, 3 degrees when you give your directions in bearings, and then surveying is always 90 degrees, right? Less than 90 when you give your answer. So here's a perfect example where it's important that you can draw the picture. So you have all you're going to get are the words. A ship proceeds on a course of 300 degrees for 2 hours at a speed of 15 knots. Then it changes direction to 230 degrees and continues at 15 knots for 3 more hours. At that time, how far is the ship from its starting point? So here's the starting ship right here. The ship is going to continue here 2 hours. When it gets to this point, it's going to change directions, and it's going to go this direction. Until it gets to here. And then it's going to turn and head home. So the question for you, I think there's going to be 2 questions. How far away is the ship from the starting point? So the blue dotted line is what we're looking for. And then the follow-up question is, what do you think the follow-up question is going to be? Now let's just assume that the speed could be staying at 15. But if you're on this ship, what's the next thing you're going to want to know? Not so much the distance. Well, how far you travel, you just add up the 3 sides. You're going to get that distance from home here. But what do you think the next question is going to be? Yeah, if you want to go home, what direction do we go? All right, that's going to be the follow-up question. It doesn't show it on here, but it does show it on the next slide. Once you've drawn a decent picture, and again, it doesn't need to be perfect, it just needs to be decent. This is what you'll see for me. I'm always going to throw these right onto the picture because it makes what we're doing a whole lot easier in terms of the angles we're doing. So the ship starts and goes from here to here. How far does the ship travel before it makes its turn? And remember, in math world, bless you, the ship turns on a dime. There's no slowdown, no turns. The ship gets to this point and goes, and it doesn't even break stride. All right, this is math world. I don't even want to hear it from you. Okay? And when it gets down here, it turns, and it's heading right back where it's supposed to. There's no time lapse, no decelerating, no accelerating. All right? Johnny Depp would have loved this kind of thing. Okay? Dude, do I have to connect all these dots for you? How far does the ship travel in the first leg of the journey? 15 knots? I don't think so. 30 knots. That's how and it's 30 technically nautical miles, 1 nautical mile per hour. So this is going to be 30 here. In the second leg of the journey, the red leg, how far will he travel? 45. Now the question is, hi Kiana, thanks. Thank you. So now they want to know, how far is it for him to get back? So what you need to start thinking about is, what about the angles here? Because that's the issue. All right? This path right here, 300 degrees, means it's 270 to here. How much is this angle going to be right here? Right in here. Over here. 30 degrees. Remember, the bearing is 300 degrees. So from north, go in this direction, all the way to here, 300 degrees. So this is 30 degrees here. We know it's 270 to the dotted line, so this angle right here is 30. Does everybody see that? Yeah. Now, if we come up to this point here, the ship is going to change directions to a 230-degree course. We know that this is 180 to here. How much is this angle right here going to be? 50 degrees. Okay, 50 degrees. Everybody follow that? If it's a 230 degrees and you're traveling starting at north, when you rotate through to here, you've gone 180, correct? How many more degrees do you need to get to the top of the boat? 50. You seeing it? Yeah. Okay. So now what you need to do is you need to see if you can find some other angles in the picture that match up by alternate interior angles in this case. All right? Anyone see any? Megan, we went ahead without you. Sorry, you were probably dozing for a minute. So we found alternate interior angles with this 60 and this 60. We found another set of alternate interior angles with this 50 and this 50. We don't need that one yet. But with this 50 and this 60, you get 110 degrees right here. That's going to allow us to find law of cosine laws to find D, which we have right here. So what does D end up going? What do we need to find with law of sines in order to find the bearing for the ship to go home?
The angle between the red and blue.
The angle right here between the red and blue, I'm going to call it theta. One ring.
Yeah. False alarm.
All right. How are we going to find it? What's the equation going to be? Sine of theta over 30 is going to equal, yeah, 62.036. Sine of 110 over 62.036. I'm okay with you using that rounded number as long as you use 3 decimals. So then your sine of theta is going to equal 30 sine of 110 over the 62.036. And you're going to do sine inverse of that. So what does theta end up being? How much? Now remember, that's this angle right here, 57.028 degrees. Is that not right?
No.
Okay. That is not, however, the bearing. Plus 50 because we're going to go from north to the blue line. So the bearing from the ship home is north to the blue line, which would be a bearing 77.028 degrees to get home. Okay? Small pictures make it hard to do alternate interior angles. Bigger pictures will make your life easier. I know. It will be a cool life. Because it's a bearing, 077.028 degrees. It's not in my wheelhouse, that's why.
John's right.
All right, see if we can set, this one's set up again picture-wise for you. See if you can find the bearing from C to B. So what can we put in so far? Okay? How far? Oh, I thought you said from B and T. From T to C is 4. What else? Yeah, the given information is good. You got that without any work? We should all be so lucky. What else did we give you in the? What else did we give you in the problem?
8.
8 from T to B. Now it says city C is 4 kilometers from T on a bearing of 150 degrees. So from T to C is 150 degree bearing. What does that tell you? So from north, on the T, we're going to go this direction, this angle right here, 150 degrees. So inside, we get a 30 degree angle right here. And that may or may not help you. The interior angle thingy, we're using technical talk now. Right here. That is also 30. So then this angle in the new math is going to be 60. What else can you get that you may or may not need? What else can we get? So alternate interior angles, 45 degrees, which means this entire angle is 75 degrees. And that's what we're going to use and will allow us to find the distance from C to B, which I have labeled as little t. No. This angle? From this angle right here is 45 because it says city T, town T, is 8 kilometers northeast of village V. So north is here, east is here, northeast is halfway between. Well, from north to east it is, isn't it? So northeast will be halfway between, which means a 45-degree angle. All right? So what's the formula? What's the equation that's going to allow you to find T? No. No? Yeah? Yeah, we can do log cosines. Yeah. So what's T going to equal? 8 squared plus 4 squared. .965 kilometers for T. What? I don't know. Uh-huh.
I know.
7.965. Is there a mistake? Now, the other thing we need to know is the bearing. What is the bearing and distance from C, or of C from V? So we're going this direction. Again, I should be so lucky that you can just look at it. So if you're going to say that's 30 degrees, you better tell me why. The sine of theta, is this theta? The sine of theta over 4 is going to equal the sine of 75 over 7.965. So sine of theta is 4 times the sine of 75 over 7.965, and then you're going to do sine inverse of that to figure out what theta is. And again, 30 degrees, really? Could be.
29.10. Yeah, close.
29. You told me what? No, you said it was 30. 29.018. 0.18. Nonetheless, that's still not the bearing. If it's a joke, can you say? I got to get through this.
I'll write it down. For your info.
Remember, theta is not a bearing. What's the bearing going to be?
At 45.
Plus 45. So the bearing from B to C, from B to C, zero 74101. Sorry. So this is where you get a little bit more complicated. This is the area of a plot of land from a granite post. Proceed 195 feet east along Moore Valley Road, then along a bearing of south 32 degrees east for 260 feet, then along a bearing of south 68 degrees west for 385 feet, and finally along a line straight back to the granite post. The hardest thing to do, honestly, is to make the picture. Once you have a credible picture, everything works out great. But let me show you where the pitfalls are. All right, you're on the granite post, and you're going to follow Moore Valley Road, 195 feet east. And then you're going to turn from this point Q down to this point R, 260 feet, and it tells you what direction to go. South 32 degrees. So that means that right here, you need to kind of think about, I need a little bit of an accuracy deal. So again, sometimes throwing in these north-south line, east-west line is helpful. This is the 32 degrees right here. And we travel 260 feet. Now you can see my picture is not drawn to scale because if 195 feet is from here to here, 260 should be down further. So my picture is not a great picture. But again, it's really directional that's most important, at least for the most part. That's what we're going to go with. When you get down 100 or 260 feet, then you're going to go south 68 degrees west. So wherever you decide to stop, south 68 degrees west. That means this angle is the 68 degrees. Then you follow that for 385 feet. And finally, turn, so wherever this is, turn and go back to the granite post. So again, you may want to throw in these just so you can see what's what. Yes, sir.
What's that, 658?
That was the, I got nothing. I mean, I could come up with something good, but I got nothing. Any questions on filling in the picture so far, what we have? Again, all I'm going to give you are the words. All I'm going to give you are the words. And then what are they asking you to find ultimately is the area of the land. So you need to probably divide this into triangles. So that means you need some angle measurements and you need some side measurements. So we've got some sides here. We've got this side and this side. So maybe you want to divide like this. And you actually have enough information to find the area if you divide there. If we were to divide it like this. Okay, then this is 90 degrees right here, 32 degrees here. That angle in the triangle, in between the two given sides, 122 degrees. Now that poses some issues though when you come over to this triangle. So I'm not saying that's the best way to go. I'm just saying that's one way to go. Any questions on what I've filled in so far? Okay, I'm going to stop there and send you to, we'll look at other examples on Monday, but give you this as a start. 5 through 17 odds, and then you're going to have 6 to 18 evens. Our calendar, we're off. But these are the two assignments that go with this section.